Okie dokie. We're now going to transition into, in our review of the inverse functions, how to find inverses. Key thing to find inverses is if identify if the function first has an inverse and if it doesn't have an inverse, all right? So we're trying to figure out how does this function have an inverse? To figure that out, we're going to see is the function 1, 2, 1. That means for every input there's one output, and for every output there's one input. If there is an inverse, we want to find it, all right? If it exists, all right, let's find it. All right, so with that, we have this function. Now, to help us out with this one, I'm going to graph this function right here. I'm going to delete us from the previous slide, so I'm going to get rid of that. But let's go to our y equals. And in our y equals, we're going to input in this data. So you have this, and move this over a little bit. And what we're going to have is F2 guys. So if you go to math, you have TI. All right, good number. There's other faster ways to do this too, but we're going to have x plus 4. All right, and then over here we're going to have minus. We're going to have math. We're going to number. Abs. We're going to have x minus 4. Like that. So we have right here. I think we're all good. We'll go to zoom 6 just to make sure we're in a primitive window. And here is our graph. All right, so in our graph right here, we can see that this function, I'm going to take this picture over here, that this graph right here, if it's 1 to 1, then it has an inverse. So does this pass the vertical line test? Well, first off, yes, it does pass the vertical line test. However, does it pass the horizontal line test? Now the question is, this passes passes all over here. However, this is a horizontal line. This is a constant. So because that does not pass the horizontal line test, the answer is no inverse. H of x is not 1, 2, 1. All right. Well, let's try another one. So that's kind of easy. Oh, sorry. All right. Let's try another one. And we have this right here. We have v of x, this is b. All right, where it's going to equal negative 2x, the square root of 16 minus x squared. Okay. Let's try doing this one now. We'll go back here. And we'll go to y equals again. And we'll clear this. And let's plug this one in. So we have negative 2. So we're negative 2 x. And then we're going to go to the square root. All right. And we have 16 minus x squared. Squared it is. All right. Minus x squared. So that's how we're going to punch that in there. We're going to graph this. We're going to have a 10 by 10 window. So we have right here. All right, and there is our graph. Now, taking this one, all right, and I could zoom it out a little bit to get a better picture. So zoom out one time. Zoom out. We'll see. There we go. Okay. I'll take this graph, zoomed out. Look at this one once again. Is this have an inverse? Is it 1 to 1? Well, taking once again, it does pass the vertical line test. We can measure this back and forth. Yep. However, it doesn't pass the horizontal line test. Yep, does not pass the horizontal line test. No inverse. All right, v of x is not 1, 2, 1. Right, not 1 to 1. So that doesn't work out very well for us. Well, let's try another one. Hopefully, we get to some that actually do have inverses. We can figure out this right here. And this one we have is this is NC. We have f of x equals x squared minus 2. X can be greater than 0. Now, this one, I'm not going to graph. This is a basic common function. This is x squared minus 2. I'm going to graph this one, the sketch, to find out if this has an inverse. It's a parabola. I'm going to go down to 2. And normally, we have this parabola. That's what the parabola looks like. That would be the sketch. However, we are only using the side, all x values less than or equal to 0. So we're only using technically this side of the graph. Right? All the values on this side. So, does this function have inverse? Well, let's test it real quick. All right, here's my vertical line. Yes, that's the vertical line test. If so, it won't let me turn it. Oh, come on. All right, well, let's try another line. Cool thing. All right, so this right here, does pass the horizontal line test, that is. So that works out. Get rid of that. All right. So we can find an inverse. So how do you find the inverse? Well, what you're going to do is you're going to switch x and y values. You're going to switch x and y values. That helps us figure this out. It is 1 to 1. So we're going to switch the values, the juxtaposition of the two values. So we're going to find this inverse. When we do this, we're going to have x plus 2 equals y squared. We're going to take the square root. We're going to plus or minus, so it's going to be x plus 2. That equals y, which is going to be the inverse of x. Now the question is, this is what I refer to as a little keep-up function. However, are we going to have a positive or negative one? To help us determine this, we know that the range of our inverse is the domain of the function. So this one, I need to have, since this is all x values greater than or equal to 0, this would be all y values, or all x values less than or equal to 0, all y values less than or equal to 0 have to be here, which means we're talking about the negative portion. Now that we can graph this inverse out. Blue. All right, 1, 2. All right, we know it's going to be symmetrical over the y x line, and yes, you can see that. Inverse function. So yes, this would be our inverse right here. All right, the negative portion. Because of all the things that we know about inverses. Symmetrical over the y equals x line, juxtaposition of the values, x line, all right, and so on and so forth. All right, well, let's try one more. I know it's a long tutorial, all right, but hopefully this is helpful, all right, 10g, all right, g of x equals negative 2 over x, all right. Once again, you graph this, you should have, all right, right here, plug in negative values, so it's going to be positive, so you're going to have this, graph it, something like that, then plug in positive values, that, negative, all right, so we have, that's what our graph's going to look like. Now, does pass the, all right, vertical line test and horizontal line test, so this is 1 to 1, all right, 1 to 1. G of x is 1 to 1. Right? That's the horizontal and vertical line test. So we can find the inverse by switching our x and y values, okay, from our original equation. And now we solve for y. So now we'll solve for y. Let me do that, complete another slide, but I didn't. All right, so I'm going to cross multiply. And what we have then is y times x equals negative 2 divided by x. So y equals negative 2 over x. What? That is crazy. What is that all about? But yes, my friends, the inverse of this function appears to be the same as this function again, because what you realize that yes, this graph in itself is symmetrical over the y equals x line. All right, it's the juxtaposition of all its points. But that's your answer. So yes, it has to be a little weird when the inverse is the same as the function. We'll go one more. All right, this is 10e. We have m of x equals 5 minus square root of 3 minus x. Okay, so this one right here, we're moving this one up 5, 1, 2, 3, 4, 5. This is a keep up function. Moving it to the right 3, 1, 2, 3. This is going to be flipped. All right, it should look like that. Reflected over the x and y axis because we have a negative here and a negative there in front of the x. So that is where our graph is going to be. Now, once again, this does pass the this m of x is 1 to 1, so it does have an inverse. That's the horizontal and vertical line test. All right, so we can switch x and y. X is going to equal 5 minus the square root of 3 minus y, and we're going to solve x minus 5, negative 3 minus y. 5 of the negatives, we have negative x plus 5 equals the square root of 3 minus y. We're now going to square both sides. All right, make sure you don't square too much in class. That's an old math joke. All right, continuing on, we're going to subtract now the 3, subtract 3, negative y, and then divide by the negative so that we have negative quantity, negative x plus 5. 5. 5 squared plus 3, because we distribute the negative through. Remember, we're doing the opposite of all everything through. And that is going to be, well, almost. That's our inverse, because if we graph that, what you will notice is we have a whole parabola. What portion are we only using? The parabola, well, once again, we draw our line. Okay, we should have some sort of symmetry, right? Like so. So probably going to go like this. That, right? Something like that. We should have some sort of symmetry like so, right? So what is happening? Well, I'm shifting over to the left 5. 1, 2, 3, 4, 5. Then shifting it up 3. 1, 2, 3. Should be down just a bit, like right there. Okay. And we are going to be using, so that's our point. All right. And what we should then have, right, it's going to go down. So which part are we using? Well, it appears we're using the one that is less than that, right? Just to have that. So once again, look at the symmetry, we're using this portion, right? So we have to make sure we restrict the domain of all x values which are less than or equal to 5. X values less than or equal to 5. All right. I hope that helped you out. I'm doing this. Good luck. God bless with the rest of your problems. And we'll talk to you later.